Welcome. We're going to talk about polynomial and rational inequalities. First thing, a polynomial or a rational inequality must have 0 on one side. That's what all of those represent. The function on one side of the inequality and 0 on the other side. First, we're going to just look at some graphs. So these directions in our notes packet say use the graph of the function f to solve the inequality. Looking at number 1, f of x is greater than 0. That means it's everything above 0 on the y, not including 0. So here I'm going to go ahead and put open circles there where my intersection is. Once I have open circles where my intersection is, then I'm going to look, where is my graph above 0? Well, it's above 0 here, it's above 0 here, in between there, and from here to infinity. Answering then A in interval notation, my lowest possible value is -5. It's not included. To -1, not included again. Or 1, not included, to infinity. Now I'm going to erase this to look at the B part. Now for my B part, it says f of x less than or equal to 0. All right, so when is my graph less than 0? Well, it's below the x-axis. This time my 0 is included, so I'm going to color in my x-intercepts because it's including where my y is 0. That's all my x-intercepts. Here it's below, which means in this direction. And right here it's below, which means from here to here. When you're writing this, you're only writing it in interval notation. So my lowest possible value is -infinity. Infinities always get parentheses. To -5, which gets a bracket because it is included. Or then -1, which again is included, to 1. Number 2 says f of x is greater than or equal to 0. All right, so again, greater than 0 is above the x-axis. This time it's equal to. I'm going to color in my x-intercepts. So where is this greater than 0? Well, it's greater than 0 right here, which is in this direction. Right here, which is also to positive infinity. And then where does it equal 0? It actually equals 0 at 0. Writing this in interval notation, what's my lowest possible value? -infinity to -3, which gets a bracket. Or now I have to take into consideration that 0 is included. So when we write 0, we actually use set notation because it's the set of 0. Or included 3 to infinity. Now I'm going to erase this. B. B says find f of x less than 0. This time my zeros are not included. Open circle, open circle, open circle where my intercepts are. Then where is it below 0? It's below 0 here, which that interval is between those two open circles. Again, here it's below 0 in between those two open circles. So writing this in interval notation, I have not included, -3 to 0, not included, or not included 0 to positive 3 not included. Both of those are polynomial functions. Now we're going to take a look at a rational function. A says f of x less than 0. So whereas y less than 0, below my x-axis, it's not including 0. So I'm going to do my 1 intercept, which is right here. And then I see that this is the only part it's approaching that, and it's not included there anyway. So this right here, I'm going to go ahead and write a parentheses there. So my a, where is it less than 0? From 0 to, you need to make sure that you realize that each one of these hash marks here represent 2. So 2, 4, 6. That's why I'm going to say from 0 to 6, and 6 is not included. 6 is not included because it is a horizontal asymptote anyway. B asks us, when is the function greater than or equal to 0? Here's where I have it equals 0. To the left is where it's above 0, so I know it's all of those x values. Then to the right, I have that vertical asymptote, and I see that it's going to negative infinity here. That vertical asymptote, on the right side of that vertical asymptote, it's all positive. That vertical asymptote is never included, right? You can never have that x value. But then everything to the right is above 0. Or greater than or equal to 0. Writing that in interval notation, my lowest possible value is negative infinity to 0, which is included, or 6, which is not included. Even though this says it is included, it's not included as an intercept, but it's approaching that 6, but it can never equal 6. To infinity. Let's go ahead and solve some of these inequalities, more specifically the polynomial inequalities. So for number 4, this polynomial is already in factored form. Do I have 0 on the right side? Yes, I have 0 on the right side. So now I know my zeros of my polynomial are negative 5 and negative 1. So now I'm going to take a number line and divide my number line by negative 5 and negative 1. Are those values going to be included? No, they're not going to be included, so I'm going to do open circles here. Now I'm going to check, plugging in values less than negative 5, in between negative 5 and negative 1, and then greater than negative 1. So x equals negative 6. Plugging in negative 6, I have negative 1 times negative 5. Is that greater than 0? Yes, 5 is greater than 0. So that is true. So I'm going to shade that part of my number line. In between negative 5 and negative 1 is negative 2. So when x equals negative 2, I have 3 times negative 1. Is that greater than 0? Negative 3 is greater than 0 is not true. So since that's not true, I'm not going to shade in between there. Now I'm going to choose a value that's greater than negative 1. So I'm going to choose x equals 0. When x equals 0, I have 5 times 1 is greater than 0. Is 5 greater than 0? Yes. So therefore I shade to the right. Writing my answer in interval notation, I have negative infinity to negative 5 not included, or -1 to infinity, parentheses. Number 5. First thing I look at is this in standard form? Yes, it's in standard form. I have my 0 on the right side, or 0 on one side. Doesn't really matter which side. I have 0 on the right side though. Now I'm going to go ahead and write this in factored form. My greatest common factor is x. Then I have x minus 5 less than or equal to 0. So my zeros then are 0 and 5. My number line, 0, 5. You're always doing your number line in order. This time, are these values included? Yes, because it says less than or equal to, so I know that these values are included, which means when you graph it, they get, or when you're writing it in interval notation, they get brackets. Now I'm going to plug in a value less than 0, x equals -1. -1 squared minus 5 times -1, is that less than or equal to 0? Well, I have 1 plus 5, is that less than or equal to 0? 6 is not less than or equal to 0, so that's not true. Now I'm going to check a value that's in between 0 and 5. So let's plug in 1. So then I have 1 squared minus 5 times 1 is less than or equal to 0. So then I have 1 minus 5 is less than or equal to 0. So is -4 less than or equal to 0? Yes. So in between here, since that is true, we shade in between. Plugging in x equals 6, I have 6 squared, which is 36, minus 5 times 6, which is 30, is less than or equal to 0. Is 6 less than or equal to 0? No. So therefore, I'm not going to shade greater than 5. My interval notation is then bracket 0, because it's included, to 5, which also gets a bracket. Does number 6 have 0 on one side of my inequality? No. I have to have 0 on one side of my inequality, so I'm going to go ahead and add 8 to both sides. So now I have x squared minus 6x plus 8 is greater than or equal to 0. Factor that. Binomial times binomial. X is the first term in both. My signs are the same. They're both negative. My factors are 4 and 2. Once I have it in factored form, then I know my zeros are 4 and 2. My number line. 2 is first because 2 is less than 4. Are these values included? Yes, these values are included. I'm going to choose a number that's less than 2. I'm always going to choose 0. X equals 0 whenever I can. Plugging it in, I'm going to go ahead and plug it in to where I have my 0 on my one side. So I get 8 is greater than or equal to 0. Is 8 greater than or equal to 0? Yes. So therefore, this part right here is true. I'm going to choose a value in between 2 and 4. So x equals 3. When x equals 3, I'm going to go ahead and plug it back into my original. I have 9 minus 6 times 3 is greater than or equal to -8. So I have -9 is greater than or equal to -8. Is -9 greater than or equal to -8? No. So So therefore, I'm not going to shade in between there. Now I need a value that's greater than 4. X equals 5. 5 squared is 25. Minus 6 times 5 is greater than or equal to negative 8. So I have 25 minus 30. So I have negative 5 is greater than or equal to negative 8. Is negative 5 greater than negative 8? Yes, it is. So since that's true, I am going to shade to the right. In interval notation, my lowest possible value is negative infinity, which gets parentheses, 2, the number 2, which is included, which gets a bracket, or bracket, because it's included, 4 to infinity. Now we're solving rational inequalities. My directions here are still to solve the inequality. Now it's just a rational inequality. I still have to have 0 on one side. Doesn't matter what side that's on. I have to find all the zeros of the numerator and the denominator. This one's pretty easy. I can see that my 0 in the numerator, my 0 here is 1. My 0 in the denominator is negative 2. Now I'm going to do my number line. Negative 2, positive 1. Are my values included? It says no, they're not included, so I'm going to go ahead and do open circles here. Now, just like before, I'm going to check my intervals. So I'm going to plug in a value that's less than negative 2. So x is equal to negative 3. When I plug that in, I get negative 4 divided by negative 1. Is that less than 0? No. So since that's not less than 0, I'm not going to shade it. A value in between negative 2 and 1, 0. When I plug in 0, I get negative 1 divided by 2. Is that less than 0? Yes. Shade in between. A value that's greater than 1, plug in x equals 2. 2 minus 1 is 1, divided by 2 plus 2, which is 4. Is 4 less than 0? Is 1/4 less than 0? No. So my answer is negative 2 to 1, where both are not included. Number 8, do I have 0 on one side of my inequality? Yes, I have 0 on one side of my inequality. So now I'm going to go ahead and find my zeros. So my 0 here is negative 11. My 0 here is 8, and my 0 here is going to be 1. On my number line, that needs to be in order. My lowest value is negative 11. My next value is 1, and then my next value is 8. Here's where rational inequalities get a little tricky. This says greater than or equal to. So can it be 0? Yes, but you can only have 0 in the numerator. Your denominator can never ever be 0. So I'm going to go ahead and say 1 is not included, but negative 11 is included, and 8 is also included. So I have to think about that. All right, so now we need to check our intervals. So plugging in x is equal to negative 12. I get negative 1 times negative 20 divided by negative 13. Is that greater than or equal to 0? So here I'd have a positive divided by a negative. Is that going to be greater than 0? No. x equals 0 is between negative 11 and positive 1. Plugging in 0, I would get 11 times negative 8 divided by negative 1. Is that greater than or equal to 0? Well, then I have a negative divided by a negative, which is a positive. Is a positive greater than 0? Yes. So in between here is included. Between 1 and 8, let's say x is equal to 2. When x is equal to 2, I have 13 times negative 6 divided by 1 is greater than or equal to 0. Well, I have a negative divided by a positive, which is going to give me a negative value. Is that going to be greater than 0? No. Now I'm going to choose a value that's greater than 8. So I'm going to choose x equals 9. So then I have 20 times 1 divided by 8. Is that greater than or equal to 0? So I have a positive value. Is that greater than 0? Yes. Now writing my answer in interval notation, my lowest possible value is negative 11, which gets a bracket because it is included. Right here it says it's included, to 1, which is not included because you can never ever have 0 in the denominator. So even though this says included, you can never have 0 in the denominator. That's why you have parentheses there. Or 8, which is included again, to infinity, which gets parentheses. Infinities always get parentheses. With number 9, do I have 0 on one side? No, I don't have 0 on one side. First thing I have to do is get 0 on the one side, so I'm going to subtract 2 from both sides. Since I don't have a lot of room, I'm actually going to move over here to the left. So now I have x minus 2 divided by x plus 5 minus 2 is less than or equal to 0. In order to combine these here, I have to have the same denominator. What's my least common denominator? X plus 5. So I have to multiply 2 by x plus 5 so that I have x plus 5 in my denominator. So I'm multiplying that negative 2 by 1. X minus 2, and then I have negative 2 times x, so I have minus 2x, and then I have a negative 2 times a positive 5, so I get negative 10, divided by that same denominator, x plus 5. That's less than or equal to 0. Combine like terms. I have negative x minus 12 divided by x plus 5 is less than or equal to 0. What are my zeros? My 0 here is going to be negative 12. My 0 here is negative 5. Number line. Negative 12 is less than negative 5. Are my values included? Tricky, tricky. Remember, negative 12 can be included, and then negative 5 is not included. It's not included because it's in the denominator. You can never have 0 in the denominator. X is equal to negative 13. I'm going to go ahead and plug that into my original so that I get negative 15 divided by negative 8 is less than or equal to 2. When I simplify here, I get 1.875, which is less than or equal to 2. So therefore, that part is included. Choosing a value between negative 12 and negative 5, I get x is equal to negative 6. Here I have negative 8 divided by negative 1 is less than or equal to 2. So I have 8 is less than or equal to 2. My answer here is no. Plugging in 0, I have negative 2 divided by 5 is less than or equal to 2. Is that going to be true? Yes, because it's a negative value. So yes. My answer here then is negative infinity, which gets parentheses, to negative 12, which gets a bracket, or negative 5, which has a parentheses because it's not included, to infinity.